show that integral from 1 to 3 of 1 over square root of x minus 1 and 3 minus x with respect to x is equal to pi. Grace and peace to you all, and welcome back to my channel. This is Donald Siame, author of A Hidden Mathematical Genius Within Revealed. Okay, so we are still on beta functions, and here the first thing to do, we can see that here this function is a denominator. So what we can do, we need to bring this upward there. We don't need it to be in a fraction form, and we know that when you get a term from a denominator to a numerator, then the power should change, the sign should change. So if the power is positive, when you take it to be a numerator, then the sign should be a negative. And you know that here the power is half, because every square root has a power of half. So the power is a positive half. So when you take this as a numerator, then the power will be a minus half. So that's the first thing. So we have integral from 1 to 3 of, so this one is x minus 1 to the power minus half, and 3 minus x to the power minus half dx. Okay, then the other thing is for us to work out this as a beta function, one of these two expressions should be a single variable. Okay, so we let one of these two to be a single variable. So let's use this one. You say let u equal to x minus 1. Okay, then we make x subject. So if you make x subject, it's just a matter of adding 1 to both sides. So we are going to have x is equal to u plus 1. Then you differentiate x. So we have dx is equal to u, derivative of u with respect to u, it will be 1. This is a 0. We multiply by du. So 1 multiplied by du is that's du. So dx is equal to du. So when you change the variable, the signs, the limits should also change. So our initial limits were from 1 to 3, that is x. Our new limits will be in terms of u. Okay, so it's just a matter of substituting. Where there is x, we put a 1, so 1 minus 1 is 0. If you put a 3, 3 minus 1 is 2. So our new limits will be from 0 to 2. Okay, so integral from 0 to 2 of x minus 1 is u. So we have u to the power minus 1 over 2. And here where there is x is u plus 1. So if you put u plus 1 there, you are going to have minus u minus 1. So 3 minus 1 is 2. Then minus u to the power minus 1 over 2. Then dx is du. So we put du there. Okay, so if you look at this, still we don't have it in a beta function form, because for it to be a beta function, here we're supposed to have a 1. So to get a 1 here, we need to divide out these two. Okay, and you should know that when we divide out these two should also carry the power there, which is minus 1 over 2. So let's divide out 2. So it will be 2 power minus 1 over 2. Then integral from 0 to 2, that is u to the power minus 1 over 2. Then since we have divided out a 2, so we're going to get a 1 minus, we divided out a 2, so this will be u over 2 into the power minus 1 over 2 du. Again, this is not a beta function form, because for it to be a beta function, this should be a single variable. So u over 2 should be a single variable. So we let this to be a single variable. We say let t equal to u over 2. And you make u subject to the formula. So that's a matter of cross multiplication. So u is equal to 2t. Then you differentiate, because we need also to substitute du. So du is equal to derivative of 2t is 2. Since it's with respect to t, so it will be 2 multiplied by dt. So that is 2 dt. So du is equal to 2 dt. So since we have changed the variables, it means even the limits must change. So limits, our initial limits, we are from 0 to 2. The new limits will be in terms of t. So if you put a 0 where there is u there, you get a 0. If you put a 2, you get a 1. Okay. So we have 2 to the power minus 1 over 2. Then integral, the limits is from 0 to 1. Then where there is u, it's 2t. So 2t to the power minus 1 over 2. 1 minus u over 2 is t. So 1 minus t to the power minus 1 over 2. Then where there is du, it's 2 dt. Okay. So you can see that we are almost there. So first thing, we need to get to divide out the constants. Here 2, we need to divide out this 2. It has a power of minus 1 over 2. So when you multiply numbers with same bases, you add the power. So here we are going to have minus 1 over 2 minus 1 over 2. You get a minus 1. So that is 2 to the power minus 1. And here we have a 2 again, and this 2 has a power of 1, so that is positive 1. So minus 1 plus 1, that is a 0. So that is 2 to the power 0, which is just a 1. So all the constants are cancelled out. So we have integral from 0 to 1 of t to the power minus 1 over 2. And 1 minus t to the power minus 1 over 2 dt. Okay, so now this is in beta function form. So that's a matter of equating this to m minus 1 and this to n minus 1. So m minus 1 is equal to minus 1 over 2. N minus 1 is equal to minus 1 over 2. So to get m, you add 1 to both sides. So it will be minus 1 over 2 plus 1. Yes, we get 1 over 2. So we have m is equal to 1 over 2. And n is equal to 1 over 2. Okay, so this is just beta of 1 over 2, 1 over 2. And we know that a beta function is related to a gamma function. So it is the product of the two gamma functions over gamma of the sum of these two. So we have this is equal to gamma of 1 over 2 multiplied by gamma of 1 over 2 over, so 1 over 2 plus 1 over 2 you get 1 over gamma of 1. Okay, and I believe you remember that gamma of 1 over 2 is just the square root of pi. So this is square root of pi multiplied by square root of pi over gamma of 1 is 1. So square root of pi multiplied by square root of pi, you get just pi. So this is equal to pi. Hence, shown. So we have shown that this integral is equal to pi. Thank you so much for your time.